Hello students and welcome back. In today's session, we will be learning about speed and velocity, and the topics that we are going to cover today are: what are vectors and scalars? We will be studying about speed, definition and formula. We will be studying about velocity, definition and formula. And what is the effect of speed and direction on velocity? So let's begin. Okay, now first we will study the difference between scalar and vector. Now about this we have already studied in previous standard, but I would just like to revise that. Now coming to scalar quantity. A scalar quantity is a quantity that is fully described by a magnitude only. That means it is described by just a single number. Here no direction is required. Only number is enough. And some examples of scalar quantities are speed, volume, mass and time. So these are the quantities that does not require direction. You can just say that now the time is 10 o'clock. No direction is required here. Now in opposite to this, coming to vector. A vector is a quantity that has both a magnitude and a direction. Vector quantities are important in the study of motion. And some example of vector quantity includes force, velocity, acceleration and momentum. So vector is a quantity that requires number as well as direction. So I hope now scalar and vector is clear to you. Next. Now going to speed. Now let's first see what is the definition of speed. Okay, you always say he is driving with a fast speed, he is driving the car with a slow speed. So what exactly the speed is? So the speed is basically the rate at which someone or something moves or is able to move. Now in this lesson, as we have discussed, we are studying about motion. Motion means movement. Okay, so decide how fast or slow a person moves, we usually express it in the form of speed. Its SI unit is meter per second. And if I want to find out what is the speed, the formula to find out speed is distance upon time. Now you can see this example, a car is traveling this much distance in this particular time. So if I want to calculate the speed of the car, it is speed is distance upon time. Then the next is velocity. Now let's see what is velocity. The distance traveled in one direction by an object in unit time is called its velocity. So basically the distance traveled in unit time. Now this unit time can be 1 second or 1 minute or 1 hour. There is one more definition. The displacement that occurs in unit time is called velocity. So in the previous topic we have studied distance and displacement. Okay, so displacement occurs in unit time is also called velocity. So coming to the formula of velocity, velocity is equal to displacement upon time. Now suppose let's study with the help of this example. Okay, so now this car is moving in a particular direction. We can see that it is say moving from A to B or B to A, and the distance is or the displacement is 600 meters. And the car takes 30 seconds. So according to the formula, velocity is displacement upon time. That is 600 upon 30 is equal to 20 meter per second. So we say that the car is moving with a velocity of 20 meters per second. So you can see that the speed and the velocity, the units are same. Now let's see some important things about speed and velocity. As I already told you, the unit of speed and velocity are the same. In SI system, the unit is meter per second, whereas in CGS system, it is centimeter per second. Speed is related to distance while velocity is related to displacement. So as we know that displacement and distance are the two sides of a coin. So speed and velocity are also related. Then the next is, if a motion is along a straight line, the value of speed and velocity are same, otherwise they can be different. So if the movement is along the straight line, then the speed and velocity's values are same, otherwise it is different. Velocity is the displacement that occurs in unit time. This also we have discussed. Okay. Now let's see the effect of speed and its direction on velocity with the help of this small video. Please pay attention.
Effect of speed and direction on velocity. Sachin is traveling on a motorbike. Explain what will happen in the following events during Sachin's ride. 1. What will be the effect on the velocity of the motorcycle if its speed increases or decreases, but its direction remains unchanged?
Okay, so what is the example here? The speed is increase or decrease, but the direction is same, but it is going to affect the velocity.
2. In case of a turning on the road, will the velocity and speed be the same?
When there is a turning, do you think the velocity and speed will be same? No, it will be different.
If Sachin changes the direction of the motorcycle, keeping its speed constant, what will be the effect on the velocity?
Now direction is changed, speed is constant. What will happen? Again the velocity will change. So in all the case we can see that the velocity is changing.
3. If on a turning, Sachin changes the direction as well as the speed of the motorcycle, what will be the effect on its velocity?
Now direction is also changed, speed is also changed. What will be the effect on its velocity? Of course, velocity will also change.
It is clear from the above that velocity depends on speed as well as direction, and that velocity changes by 1. Changing the speed while keeping the direction same. 2. Changing the direction while keeping the speed same. 3. Changing the speed as well as the direction.
Okay, so we can see that in all the three cases, okay, the velocity is changing. So whether you change its direction or you change the speed or you change either one of them or you change both, in all the cases it is going to affect the velocity. Now let's see some more information.
Always remember, the first scientist to measure speed as the distance upon time was Galileo. The speed of sound in dry air is 343.2 meters per second, while the speed of light is about 3 multiplied by 10 raised to 8 meters per second. The speed of revolution of the earth around the sun is about 29,770 meters per second.
Okay, so I hope you are clear with this video. Okay, so towards the end, let's recap about speed and velocity. We have in this module, we have studied vectors and scalars. Okay, we have studied about speed and velocity and what is the effect of speed and direction on velocity. Thank you and take care. Okay, now let's study about uniform and non-uniform linear motion. what is uniform and what is non-uniform linear motion. To study this, we will study one example. The example says, Amar, Akbar and Anthony are traveling in different cars with different velocities. The distance covered by them during different time interval are given in the following table. Children, please open your textbook and go to page 4 to refer this particular experiment. Now, if we see the values in the table is divided as time is given in the clock, distance covered by Amar in kilometer, distance covered by Akbar in kilometer, and distance covered by Anthony in kilometer. The time interval is given at 5, 5:30, 6, 6:30, 7, 7:30 and 8, and these are the distance covered by these three person, Amar, Akbar and Anthony. If you see at 5 o'clock, that is starting time, the distance is 0. They are starting from distance 0, and then gradually the distance keeps on increasing. Now look at the values, that is distance covered by Amar in kilometer. The values are 20, 40, 60, 80, 100 and 120. That means it is increasing in one particular order. If you see the distance covered by Akbar, it is 18, 36, 42, 70, 95, 120. Here the distance is not increasing uniformly. Whereas if you see the distance covered by Anthony, again you will see that the distance is 14, 28, 42, 56, 70, means 14 stable. That is, it is coming a uniform distance. Now let's solve some questions based on this. What is the time interval between the notings of distance made by Amar, Akbar and Anthony? And the answer is 30 minutes. Who has covered equal distance in equal interval of times? From the table very clearly we can say that it is Amar and Anthony who has covered the equal distance in equal time intervals. Are all the distance covered by Akbar in the fixed time interval are the same? The answer is no. Consisting the distance covered by Amar, Akbar and Anthony in fixed time intervals, what can you say about their speeds? Amar and Anthony moves with a uniform speed and Akbar moves with a non-uniform speed. So that gives rise to new concept, uniform speed and non-uniform speed. Now let's see the definition of this. What is uniform and non-uniform speed? If an object covers equal distance in equal time intervals, it is said to be moving with uniform speed. Whereas this example of uniform speed is motion of heavy vehicles like truck on highway. If an object covers unequal distance in equal time intervals, it is said to be moving with non-uniform speed. For example, the motion of a vehicle being driven through heavy traffic. Now both these situations you must have experienced. When the road is clear, the vehicle moves with a constant speed. So that's a uniform speed. Whereas whenever traffic is there, the vehicle is not moving very fast. It stops and then goes again. So that we call as non-uniform speed. Okay, so I hope you all are clear about uniform speed and non-uniform speed. Now next concept we are going to study is a acceleration. Let's see what is acceleration.
Acceleration. Let's try this. 1. Take a 1 meter long plastic tube and cut it lengthwise into two halves. 2. Take one of the channel-shaped pieces. Place one of its ends on the ground and hold the other at some height from the ground as shown in figure 3. Take a small ball and release it from the upper end of the channel. 4. Observe the velocity of the ball as it rolls down along the channel. 5. Is its velocity the same at all points? 6. Observe how the velocity changes as it moves from the top, through the middle and to the bottom.
Okay, so you can see here that a ball is released from the top. So what do you think, children? Will the velocity of the ball be same at all the points? What is your answer? No, it won't be same at all the points. In the beginning, it will be less. Then it will go on increasing, increasing, increasing. And when it touches the ground, will the ball stop? No, it will go some distance and then when the velocity becomes 0, it will stop.
You must have all played on a slide in a park. You know that while sliding down, the velocity is less at the top, it increases in the middle and becomes 0 towards the end. The rate of change of velocity is...
Okay, so that gives us the definition of acceleration. The rate of change of velocity is called acceleration. So if we see the formula of acceleration, it is change in time change in velocity upon time. If the initial velocity is u and the time is t, it changes to final velocity v. Then acceleration, which is denoted by a symbol a, is defined as final velocity minus initial velocity upon time. That is, if we use the symbols, it is a is equal to v minus u upon t, where v is the final velocity, u is the initial velocity, and t is the time. If the velocity of an object changes during a certain time period, then it is said to have an accelerated motion. An object in the motion can have two types of acceleration: uniform acceleration and non-uniform acceleration. Now in the previous one we studied about uniform and non-uniform speed. Now we will be studying about uniform and non-uniform acceleration. So let's see what is this. If the velocity changes by equal amounts in equal time interval, then it is said to be a uniform acceleration. Whereas if the velocity changes by unequal amounts in equal time intervals, the object is said to be a non-uniform acceleration. Okay, so in both the case, time is same. In the first case, velocity is changing by equal amount, whereas in second case, velocity is changing by unequal amounts. Use your brain power. When an object is at rest in the beginning of its motion, what is its initial velocity? And of course, the answer is 0. When an object comes to rest at the end of its motion, what is its final velocity? Again, the answer is 0. Now, there can be three types of acceleration: positive, negative, and 0. Now, the first example, let's see. When the velocity of an object increases, the acceleration is positive. In this case, the acceleration is in the direction of velocity. See the example, velocity and acceleration, same direction. So, positive acceleration. Whereas, when the velocity of an object decreases with time, it has negative acceleration, which is also called as deceleration. its direction is opposite to the direction of velocity. So, velocity is in this direction and acceleration is in this one. So, it is a negative acceleration. And if the velocity of the object does not change, look at this car, it is a stationary car, then it has a zero acceleration. Okay, so I hope you are clear with the concept. Thank you very much and take care.